Okay, here's a question on the SAT requiring us to solve a rational equation. Now, the most efficient way of answering this question is using decimals, but let's read the question first. What is the value of x that satisfies the equation above? This is a fancy way of asking you to solve for x. And again, we can solve this algebraically, or we could use decimals. By far, decimals is the easier thing to do. And I'm going to start off by showing you the decimals method. But for those studious scholars that want to see how to solve for this manually, then I'm going to follow that up by showing you how to solve for this equation using algebra. So off to decimals we go. So all you need to do is simply type in this equation into decimals, as I've already done over here. Quick tip is if you want to enter a fraction, you best use the slash symbol on your keyboard to immediately bring up a fraction symbol for you. Makes it easy. Anywho, so once you graph this, remember, you're looking for the solution. What does that mean? Where the graph is crossing the x-axis is where the solutions are. So if you look closely, you will find that this graph that came up is crossing the x-axis at 0.5, which is 1/2, and that makes C the correct answer to this question. But as promised, for those students who want to see the longer way of solving this, just so we can review a lot more concepts, let's go ahead and do this manually using the algebraic method. So here we go. Remember, when you're solving fractions, either adding or subtracting fractions rather, you always start off by finding the least common denominator. Some people say least common multiple is the same thing. Now, when you look at these fractions, we have three different denominators. First, you always want to make sure you can factor anything that's factorable. So we look at this and we go, yeah, that can be factored. It's a difference of squares, which factors to x plus 3 and x minus 3. And the rule for solving these equations to find the least common denominator, each item in the denominator needs to be represented. So we have x plus 3 and we have x minus 3 in the denominator. The rest is pretty simple. All you do is you look at each denominator, like x plus 3, x minus 3, compared to the least common denominator. It's not missing anything, so that one's fine. We're not going to do anything. Let's go to the next denominator, which is x plus 3. Compared to the LCD, it's missing x minus 3, so we need to multiply this one by what it's missing, and that's x minus 3. And last but not least, you're going to compare the last denominator, which is x minus 3, to the LCD. And again, you will notice we have the x minus 3, but we are missing x plus 3. So you multiply this one by what it's missing, which is x plus 3. All right, so rest is just computation. We're just going to compute this. Look at the left side. So this first one, we didn't multiply by anything, so nothing changes. So we still have the 4x squared. The second one, however, we are multiplying the negative 2x. Yes, be mindful of this sign. It goes with that term. We're going to distribute this negative 2x into both of these. So negative 2x times x becomes negative 2x squared. Negative 2x times 3 becomes positive 6x. Equals. So on the right side, we have 1 times x plus 3. And of course, that's not changing. It is still x plus 3. So now what we have here in front of us in the making is a quadratic equation that we need to factor and then solve for x. So first of all, let's combine these like terms. This becomes 2x squared plus 6x equals x plus 3. Recall, when you're solving a quadratic equation, you must set it equal to 0. So let's move everything to one side. I'm going to subtract x and I'm going to subtract 3x. Whatever you do to one side, you got to do to the other side. Those are gone. So we end up having 2x squared plus 5x minus 3 equals 0. And to factor quadratic equations, there are many methods, but the one we've been using over and over again is what's known as the x method. Here we do product, which is a times c, and we do sum, which is the b value. The a value is 2 and the c value is negative 3, so a times c is negative 6. The b value is the middle term, which is 5. So we ask ourselves, what two numbers do we multiply together to get a negative 6? And then when we add those numbers, we get a positive 5. Well, the factors of 6 are 1 times 6 and then 2 times 3. Those are the only ways we can multiply two numbers to get a 6. Now, which combination would give us a negative 6 when we multiply and a positive 5 when we add? So if we look carefully, you will see that this top one is the one that would work. However, we would need to make one of these numbers a negative, and that would have to be a -1. Let's examine this. What's 6 times -1? It's -6. What's 6 minus 1? It's +5. So we found a pair that works. And once you do that, you can immediately set up your two parentheses like that. And then you're going to end up saying x plus 6 because our 6 is positive over here. And then you're going to end up saying x minus 1 because our 1 is negative. Now, please be mindful of this. Because the leading coefficient is not a 1, we have a 2 right there. There's a shortcut. This is called the slide and divide rule, method rather. It's a time saver. So we divide both of these by whatever the number is there. If that was a 1, we would have been done with the problem, but it isn't. So we have to divide by that coefficient. So this becomes x plus 3. And then on the other one, you notice that this is not divisible really, right? So don't fret. Simple rule is you drag that number and you drop it at the very beginning. So this becomes 2x minus 1. That equation is fully factored. All we need to do now is solve. So we'll take each factor, x plus 3, set it equal to 0, and the other factor, 2x minus 1, equals 0. And then you use algebra to solve for x. So these cancel, x equals -3, and the other one, you would add 1 to both sides, and you end up having 2x equals +1, divide both sides by 2, x ends up being 1/2. So you look at the answer choices, and it's asking which satisfies the equation above. You might be perplexed that both answers show up. We have x equals -3, that's choice A, and then we have x equals 1/2, that is choice C. Which one do we go with? Well, you never want to use an x value that makes the denominator a 0. You would see that this one fails, because if you took the -3 and you plugged it in right here, you'd have -3 plus 3, making the denominator a 0. So this answer we must exclude because you cannot divide by 0. You'd have to go with this answer right here. But again, as I said, Desmos to the rescue for this kind of question. If you see it, plug it in, quickly use Desmos to find where the graph crosses the x-axis. Adios.